And then hi everyone, and welcome to another Azure Greg live stream. Tonight I'm going to be talking to Craig. Craig, hi, how are you?
Yeah, doing well. How are you?
Good. Yeah, I'm good. Thanks for coming on. So tonight we're going to chat about Cosmos DB. That and a few other things, no doubt. So tell us a little bit about yourself, Craig, because a lot of people might not know who you are. So who is Craig Nicol, and what do you get up to in your spare time?
Yeah, so I've been C# developer for about best part of 20 years now, and yeah, doing most stuff around Azure for the last 10ish years. So yeah, been doing a whole bunch of different projects, working mostly with consultancies. So all the fun stuff of learning new clients every 3 to 6 months, which is always good. Lots of stuff in the public sector, lots of stuff in a few things in banking and things like that. So get to touch quite a lot of stuff. Starting a new job in a couple of weeks. Lots of new adventures.
Good. It's always good. Let me just say hello to Susheta. Hi, Susheta. Thanks for joining us as always. She's always on, so thanks very much for joining us. So you're looking forward to your new job? That'll be good in a couple of weeks' time. It's always good to do something new.
Oh yeah. That's it. You do you get a bit. Yeah, you get a bit bored, get a bit tired doing the same thing. So I love starting new things and learning new domains, and that's one of the reasons I got involved in Cosmos DB. Initially, just like I haven't used this before. This looks quite interesting. So
it's when I think a lot of people don't understand Cosmos DB, and when you look into it and start reading about it, it's super clever technology. It really is. The fact that you can, like, the guaranteed speeds and things like that, and the global nature of it and things like that, which we'll get into. Right, so let's start off talking about Cosmos. So I've got a list of like idiot guide questions, and we'll just start with that if that's all right. So for people who don't know, what is Cosmos DB and what is its kind of key features?
When the big sales pitch that Microsoft have with it, it's globally distributed, massively scalable, multi-model database service.
What does that really mean, though?
What that really means, really. Globally distributed. So basically, there's a whole bunch of nodes you can have across the world. As you know from Azure, there's a whole bunch of data centers. The idea is with Cosmos DB, you can just enter in through any of the nodes around the world. You've got to enable nodes, the idea is you can have the same data wherever you are in the world. And a lot of the way it does that is rather than doing like big massive replications, it'll do basically the smallest replication it can. So there's a whole bunch of clever stuff behind the scenes where it does diffs and patches so that it's sending data, as little data as possible around the world, which is really, really clever, really cool. It's massively scalable. So the idea being that you can just throw more and more data at it, and it handles it. As long as you've got the credit card to pay for it once it gets to the bigger levels. And then multimodal. So the key idea with that one is it's not just document database. So JSON documents. You can also have table-based, graph-based, a whole bunch of other things built on top of this JSON document storage platform.
It's free to get started with it now, isn't it? I saw something earlier that you can try it for 30 days free. Is that new?
I think that's fairly new. I think that came in and build this year. And it's one of these things. It's like a lot of things on Azure. It's like it's really cheap or free, like up to a certain level, and then your costs start ramping up once you get past it. But it's fairly cheap to get started, and there is a desktop version that you can run. So it's just for development, but you can get running with that locally, and it doesn't cost anything to run that.
So that's like an emulator, yeah.
Effectively, yeah. So it doesn't have the full feature set. There's a whole bunch of multi-threading stuff which you can't do locally. Right. But it does have that capability. So I found that very, very useful for unit testing things when I was doing that.
Yeah, it's good because when I first started using Cosmos a wee while back, it was quite expensive to begin with. and I think a lot of people didn't really understand it and spent a lot of money with it. So they've kind of went from like it's very expensive to it's now free. Please go try it, which I think is a good move. Yeah,
Yeah,
I like the fact that more Azure services are doing this because I think in the first few months of Cosmos DB and first few years, I think people were getting burned by it, and it's a shame because it's an amazing technology. And we'll dive into a lot of the technology when we're chatting about it tonight. But I think it's a shame that one or two people got burned by it when it was first out. Okay, yeah, sorry. On you go.
No, I was going to say, yeah, like yeah, it's one of the things that, because I think it does have a bit of a confusing cost model to start with. So yeah, I'll clarify terms as we go. So the key thing with Cosmos DB pricing is you've got this thing called a resource unit. So I use per second, and it doesn't quite fit, I think, like our models of how lots of other things are priced. But fundamentally, a resource unit is a bundle of compute. So it's like a mixture of CPU and memory time. And the idea is you spend money based on how many of these things you use. So yeah, just like with a normal database, if you've got the proper optimization, if you've got the if you've got smaller data sizes, you're gonna spend less doing that. If you've got really complicated queries, you're gonna spend more. Yeah, it's just a little harder to track between them. But that's one of the nice things about the emulator is that you can find out how much something's going to cost running it locally right before you try running anything on the cloud.
Yeah, that's the beautiful thing about that now. You can kind of try it and see how much it's going to cost and stuff like that. Right, okay, so next question I've got is how does it ensure the global distribution and scalability? So you know what it's like, it says it does it, but how does it actually do it under the covers?
So, well, yeah. So I say the key things it's got is that it tries to minimize the amount of data going across the wire. So it basically does diffs on what you're coming in, and behind the scenes, there's a whole bunch of patch requests. So yeah, if you've done the rest stuff and the verbs under there, so it'll figure out. So whichever your master node is, the right node that you're writing to, that will figure out the diff and then send out that patch to all the other nodes that you're running on. So therefore, I say the least amount of data going across the wire, which is very useful for us. So first time I used Cosmos DB, we were trying to sync between North America, South America, and Australia. North America, South America is fine. There's lots of cables there. Nice and fast connection. But as soon as you get across to Australia, like the latency just drops dramatically.
Oh, really?
Yeah. Like Australia is just kind of cut off from the rest of the world. It's not just Azure. Like all the services have this problem. So by minimizing the amount of data there, we could have real time service in Australia that worked with everyone in America as well. They've worked really hard on that side of things to minimize the amount of data that needs to be sent across. I'm sure we'll get to it later. There's like you can tune it to to see how much latency there is. Depending on how much consistency you need in the data.
Because there's lots of that different consistency models. We'll come on to that. So if I was going to ask you, what's the difference between traditional SQL Server databases that are relational and kind of Cosmos DB that's non-relational? For people who don't really know this stuff, how would you try and? It's quite hard to explain to people when they're used to seeing SQL and the tables, and then all of a sudden you've got JSON documents that aren't really related to each other. To be honest.
That's it. They aren't related to each other. The rough comparison is that you got your JSON document inside Cosmos DB, and each JSON document is kind of a row in a table in SQL Server. It's a little bit richer than that because you can have hierarchies within that JSON data, and you can index into those hierarchies as well. So imagine you've got like an address. That address has a country inside it. You can index by country, within that data. So rather than having to have a fixed schema like you would do in SQL Server, you've got this emergent schema. As you add new records, the Cosmos DB will look at it and figure out what the new fields are, and then you can put in just as you can do in traditional databases. You can add indexing on top of that one and say we're going to index by, we're going to search by country a lot of the time. So let's put an index on for that. And it'll figure out what it needs to do and to add those indexes in. So that's one key difference is obviously you've got this document stuff rather than any of the relational stuff. So you do need to put in a bit more work if you've got those relations going on. But the other part is because you've got this slightly more flexible model, rather than having your ACID model and your ACID consistency like you would have in a traditional database, you can tune the consistency to match better your use cases. So the key thing there being, so Internet of Things is one of the key things that Microsoft talk about for for Cosmos DB. So you've got this massive stream of data coming in. You can you can just be writing as much data as you like from all your devices around the world, and then you just set your consistency level to say, right, and then these things over here, which are going to do the analytics, they will wait until you've got a consistent set of data. But this other bit here, which just does immediate alerts back to customers, so you can say, the temperature's gone up to 100 degrees. Let's send an alert back. You can have that working at a much more much faster consistency level. So you can be setting off. You can have certain things querying the data as it comes in, like in the same session, and other things that query the data at a certain delay. So you've got that bigger picture of what's happening across all your sensors. Yeah.
So like, when I think out loud, I think like when I think of Cosmos DB, I think like, I don't know, a sensor sending temperature information, and maybe every minute it will send something. Each document would be everything to do with that temperature for that minute. That's the kind of thing. That's kind of weird, and it's just like one document rather than having separate tables that are all linked together. Is that kind of
yeah. So you got one document which contains everything you need for for that particular reading. And you could well have complicated sensors there. So you've got one sensor which has temperature and air quality and whatever else, and that'd just be one data blob. And one of the really nice things, because it's schemaless, you can have multiple versions of these sensors out in the world, all sending slightly different versions. So some will have an air quality sensor, some won't, but it doesn't really matter. You can just put in the data, and it can recognize what that data is as it comes in. You can have the idea being that so long as you've annotated that data correctly, you can read that data no matter where it's come from. It means there's a little bit more work on when you're querying the data, but it gives you that much bigger, much greater flexibility when you're working with all this.
It's kind of mind bending when you come from kind of like schema structure and SQL, and then all of a sudden you're like, you can have schemaless documents. You're kind of like, how does that work? But it's actually really cool when you start using it, because you can change the schema on the fly and things like that, can't you?
Yeah. And this is the thing. So you can change schema either per source. So you can have multiple schemas within the same collection. So that's what that's effectively what a table would be in Cosmos DB. So collection with all these different documents, and they can all represent different things coming in, different schemas, different you get this really good, this really powerful way of looking at the data, so obviously it's a bit more work dealing with that, but you don't end up with the problems that you'd have with a strongly schema. It's kind of like the difference between statically typed and dynamically typed. If you've got this really strongly typed database, with a strong schema in it, if you want to add a new column to that data, then it's going to be a lot of work. You need to go back and respectively fit that to everything else. Figure out what you do with all the data that's coming in that doesn't have that field. Is it null? Is it some default value? Whereas here is because it's JSON, it's basically undefined. So you need to deal with that fact. But when you're doing the queries, you can just go, well, just give me all the data that's got a temperature reading. I don't care about the ones that don't have a temperature reading, and it just figures it out for you.
Yeah, I think when I kind of think out loud, when I come from the SQL background and then I started doing Cosmos, I was like, oh, this is going to be a lot of work. But there's pros and cons to both sides. You don't really realize it, but there's pros and cons to things like changing schemas and SQL when you have to like add a column or change a data type. That has its pros and cons as well. So for anyone who's watching or listening, don't be put off by kind of the things we're talking about, because it's really flexible and it's very cool. And it's like there's pros and cons to everything. So the more you get into Cosmos DB, you can bend it. That's the beautiful thing about it. It's very flexible, and you can do all sorts. Now, How do you store the data? Like, what's the partition ID that people read about? What's that all about?
Yeah, so the key idea here. So if you're thinking about this from a SQL Server perspective, your partition key is really your primary key. Yeah, this is the main thing that you are going to index the data on. This is the main thing you're going to be querying the data on. So this will be something like a user ID, not be your order ID. Basically, this is going to be a thing that most of the time, 90% of your queries are going to be using that ID as the way to get the data. And because Cosmos DB then knows that, it can then make sure that there's proximity between all everything that has that same ID. So all the records for a particular user end up on the same partition. So they'll end up on the same, basically the same disk. Any query involving that user makes things is really, really fast. Now, sometimes you have to do a bit more work than that because so each partition can only be 20 gig. So if you've got something like a stream of data, your internet of things, or that stream of data coming in, it might actually be that after one day you've filled up that 20 gig partition. So in that case, what you then need to think about is, well, what you can create composite partitions, and you can say, right, well, I want a partition which is that sensor ID plus a date stamp. So then you can see everything for the same day in one place. And then and this is one thing that Cosmos DB introduced with the latest announcement of the build is you can have hierarchical keys. So you can say, I got my sensor ID, and then a subset of that is your date stamp. So you can then say, anything which is producing not much data, you might have several days of data on the same partition, whereas things which are producing lots and lots of data, you might just have 1 day per partition. So scale per according to the amount of data you're getting in.
I love talking about Cosmos DB. I think it's super clever. The more I hear about it, the more I read about it, I'm just like, I wish I was working on this more often. So it's basically the way it stores. I think of it out loud as, imagine Cosmos DB is stored on VMs, for example. It's not, but let's just say it was. The partition puts the device ID 1 on this partition, and device ID 2 is on that partition, and device ID. So it's just a way of storing the data and making it faster for retrieval and indexing. Is that kind of how it works?
Yeah. So
very high level.
Yeah. So it's similar to how you've been doing Stripe and things on traditional data stuff. So you can have multiple partition IDs on the same partition, but the partition ID lets Cosmos DB know what should stay together and what should be separated. So to make all those queries as efficient as possible.
And for people who are new to Cosmos DB, when they see the six or seven different APIs, can you explain what that's all about? Because people will go, what's this? Because I've seen people going, why is there 6 different ways to do this? But there's a reason for that.
Yeah, so you got your main API, which was called SQL, the SQL API. The document, it is also previously known as document DB. And that's basically you're working directly with these JSON documents, and that's kind of the underlying API that everything else works on. So you've got that, and I think most of the people, most of the time you're using this stuff, that's the API you'll be using. But there's also there's compatibility APIs which sit on top of that one. So if you've got a Cassandra application or a MongoDB application, you can just use the Cassandra or MongoDB API, copy your data into Cosmos DB, and basically all you have to change in your code is the connection string, and everything just works as is. So then becomes your sort of document DB as a service idea. They've got a similar thing for table storage. So if you're using Azure Table Storage at the moment, which also has a few limitations in terms of global replication and things like that, you can use the Azure Table Storage API. That's one that's not been it doesn't get updated very much, but the idea is that makes it easy for you to get from your existing Azure Table Storage into Cosmos DB with a sort of very low friction. But the idea is once you're in there, you can then start using the SQL API on top of that. And then the other main API is the Gremlin one. So this is graph based. So if your data is nodes and edges, so relationships, then you can use that. But as they all run on top of JSON, the JSON SQL API. So it's just they just have to take the structure they expect to see in that JSON. So you can have a look at Gremlin, for example. Gremlin has a very defined format and says, this is what the JSON looks like. This is how you define your nodes and edges. And so the SQL API, you'll just go in and you'll see JSON documents that look like exactly the Gremlin specification. But of course, because that's a well-defined specification, you can then have your additional query facilities on top of that.
There's also, when you sign up now for a Cosmos DB account, you get a free tier. Well, not a free tier, you get a free, well, it is a free option, but is it something like 25 gig free or something like
that? I need to double check. That sounds about right. Yeah.
That's quite a lot of JSON documents when you think about it. So yeah, that's pretty cool.
Yeah. A lot of the documentation sort of says like, JSON document is about 1K, and really, unless you put in like lots of binary data in there, so photos or anything, 1K is probably quite reasonable. So there's an awful lot you can get for reach those limits.
Totally. What about backup restore options for Cosmos DB? What are they like?
So I have to admit, I haven't looked at the stuff that's most recent about this. But the default approach is that there is automatic backups. So you've got like I think it's either 4 or 8 hours old backup. Generally, you can't access that. It's very much here's your data. Keep running through the data. If you do want to do rollbacks and things like that, there is options to get there to basically take that data out and push it onto other services, and it may well be that's the easiest thing to do. It's not really designed for quick undo rollback and anything like that. But what you do have, I'm sure we'll come to this, talk about it a bit more. There's change feed. So basically, every time you put anything into Cosmos DB, you get the change feed. Basically for free out of the service, and this gives you details of everything that's changed, and you can stream that directly to Event Grid, Event Hub. You can stream it to cold storage if you want. So you just have a backup sitting that way.
Cool. Change feed's actually really cool, but we'll come back to that. What about how does Cosmos DB do indexing, and what sort of options have you got there?
So I guess I started talking about this before. That you can have the sort of automatic indexing that comes in. If you start doing once you start with partitions, obviously you get that indexed for free, and then there's certain data that it'll recognize. Cosmos DB recognizes and has ways to index that. Numerical data will be indexed in a particular way. String data gets indexed in a particular way. So for example, you've got your name and your age in the database. Obviously, age becomes a number, and then you can start doing queries based on comparisons, greater than, less than, type of stuff. So you can filter out all the children in the database, for example. String, you get indexed, so optimized for comparison queries, just equals, not equals, things like that. But then you can also give hints to Cosmos DB. You can say there's additional things you want to index. So if there's particular things that you're going to be querying, so as I was saying before, like if it was like address, country within the address, so you can say address/country is an index that you want because you're going to do lots of queries on that. You can have and then there's additional data types you can have there. So you can have a geo data type. So you can say, right, I want to know where this person is, and I can do queries there to say, well, find the nearest warehouse to deliver to that customer, for example. So if you know that that's going to be a common query, you can do geo-indexing based on their address, and you can have that stored so you can do those queries much faster.
Cool. So my 2 jobs ago, I did a lot of Raven DB, which was quite an interesting. Going from SQL to NoSQL was a bit like mind bending. I can't say that tonight. Mind bending. So, can you try and explain what the idea of eventual consistency and things like that are? What are the consistency models in Cosmos DB? For people who don't probably know what that even means, give us some intro into what that is all about, if you can.
Yeah, so well, I guess this is one thing that Cosmos DB does differently to anything else. So yeah, if you're using like RavenDB, MongoDB, any of the other sort of NoSQL databases, they've got a consistency model, and that's kind of what they use. Whereas Cosmos DB allows you to have multiple consistency models, so you can decide based on the query that you're running which type of consistency you want. So Cosmos DB has 5 different consistency levels. In fact, this might be a place where it's easier just to share.
Read yeah. And what's is the idea behind it? How what's the word I'm looking for? How real time the data is, because the data is not always up to date. Is that kind of what it's trying to deal with?
Yeah. So the idea is that if you're prepared to give up having a consistent view of the data, then you can get that data faster. So as I was saying, in that sort of Internet of Things example, you might want to say, actually, I really care about getting the data for this particular sensor as quickly as possible, so I can tell the user that temperature's gone up to 100, air quality's gone past the threshold, whatever. But you only care about the consistency for that particular data stream. And so you can have something that runs in the same process that is saving that data, and you can get consistency amongst just within that one bit of data. But then if you want to look at everything's happening across the whole picture, you need to have a stronger level of consistency, because you want to make sure you've got the right data from everywhere, no matter where that was written, which node that came in around the world, no matter what else was happening with the streams coming in. So you can say so you can have a default for the collection itself, and then for each query you can have consistency levels. So the key consistency levels, you've got eventual consistency, which is what you'd have for most of the sort of NoSQL things. So the idea with eventual consistency is at any given time you don't know what this is, you don't really know what the system is, but if you look back to yesterday, you've got a pretty good picture of what happened yesterday. But if you're looking now, you've got there's going to be some variance in like the most real time up to date data. And this is the model that you're used to from like Facebook and things, for example. So it's like you put that post on Facebook and you can see straight away that you've made that post. But your friends might not see it for another hour or another day. And it doesn't really matter that they don't see that post straight away. Whereas there's other things where if you go in and you change your profile picture, that's the sort of thing that they want to make sure everyone sees straight away as soon as you log in. So you got a stronger consistency level there.
It's interesting when you're talking to somebody who doesn't know about that stuff, they're like, why would the data never be consistent? Like, why would it never be up to date? But then when you explain it to people, it kind of makes sense.
I think Facebook's a good example of that. It's like, you don't go in, you don't expect to know, like, what does the latest post for everywhere look like on Facebook? There isn't a good way to answer that. You know what your own posts look like, and you've got a fair idea about what your friends' posts look like. But beyond that is just like the amount of data that you need to be able to see the global picture is just too much. You just
once
can't.
You explain it like that, it makes a lot of sense, But when you're first talking to people about NoSQL, they're like, "What do you mean it's not there?" Right? When I make an update, and you're like, "It'll be there eventually," and they're like, "You can see the alarm bells going off in their head, going eventually." What do you mean eventually? It's but it's there's reasons for it, and there's ways to mitigate that. So if anyone's listening, don't worry about that. Right, what about what's the pricing models like for Cosmos DB? How's it? The costs are just calculated like you said before. It was the RUs. Is that kind of how it works?
Yes. So that's the key idea. So you've got your resource units. So fundamentally, the billing is based on resource units per second. So the idea is the queries that is really well optimized, that'll be one resource unit, whereas something which is unoptimized or saving a big document with lots of binary data in it, so profile pictures or whatever, will take several RUs. And then, you get billed on the number of IUs you're using per second. So I think by default you get, it's either 200 or 1,000, and I can't remember off the top of my head.
I think it used to be 400.
It's not I keep changing.
I think it was 400. It's now 1,000. Yeah, I think so.
Yeah.
Yeah, cool. Ahmed's just saying really interesting discussion. Yeah, I think Cosmos DB's one of the most interesting things in the whole of Azure, to be honest with you. I really do. I wish people would spend more time with it. Right, okay. What else have we got? What about, this is one that I was never really sure about. What's the security features like for Cosmos?
Yeah, so I mean, you've got your sort of standard security stuff, I guess. So you got secure at rest, and everything's secured in terms of your storage and things like that. You certainly don't have as much security as you would do on things like SQL Server. So if you've seen the sort of the latest stuff you can get in SQL Server, where you've got like row level and column level security, there's less of that certainly in Cosmos. Although they are starting to do things similar to the column security, so you can say for particular fields within that JSON, you can say, well, actually, you need to have additional permissions to be able to do that. Certainly it's not as
it doesn't have things like data masking and things, does it? No, not yet.
And it doesn't have data masking out of the box, but there are ways of doing it. There is an example. Well, there used to be an example, certainly. So you can have what they call so in the programmability part of it. So you've got UDFs, user-defined functions, and stored procedures. And you can use those as a mechanism for data masking and things. So, for example, you can make sure that the only way to retrieve certain data about a customer would be through the UDF. And then that UDF would mask the data, so you can make sure that certain bits of data don't come out. So we were using those for some of the queries in the system I was running, system I was building. This was an auction site, and we use UDFs to summarize the data. So we're doing aggregation on the data to pull it out. And you can just as easily use it for, data masking and things like that. So there's certainly been examples of that. And within those, within that programmability, you can verify the particular user. So if you've got an Azure AD login, you can track against that user. You can say, okay, this user was the editor of this blog post. Therefore, I'm going to let them see all the data for that blog post. That sort of level of scrutiny. Now you need to write all these in JavaScript. So
I got caught out with that when I first went to do that. I was like, JavaScript, that's interesting, and then I was like, okay, it's definitely different when you see people going, I'm writing a database thing in JavaScript, but it's actually not too bad. There's lots of examples out there, so don't worry, folks. What about monitoring and diagnostics? How easy is it to monitor what's going on?
Yeah, so obviously, you've got your standard metrics that you get for anything in Azure. So you can see your performance levels. So you can see how many IUs you're using per second. How that matches against your quota. So the idea is you can prepay, let's say 1,000 IUs a second, and you can see how close you're getting to that. You can have your alert set up so that if you're getting close to that, you can do your standard sort of scaling up strategies. So you get all that sort of standard stuff you get built in with Azure, and you can annotate certain bits of that as well, into the via application insights and those sort of things. The one really interesting thing that you can get if you're monitoring that, if you want to see what's causing what's causing you to use lots of IUs, there's annotations you can get. So as you're running the queries. So because Cosmos DB is all sort of HTTP based, it's just an HTTP flag you put in, and you can get back statistics for that particular query. So exactly as you expect to see in SQL Server, you can see the performance of a particular query. So it'll send back information and tell you, here's the here's how many IUs it took, and there is a little bit of information there to say things like, is it basically a table scan or a quick or something that's found in the index? So you can help tweak the information there, so you can see Which obviously helps you, plan your database and set up any new indexes that you're missing, or think about your partition keys. That's something that you may need to change. And then other things you might want to do for monitoring. If you're monitoring the data itself, so the change feed allows you to do additional monitoring on that. So you can be looking at things. If you're looking for patterns in data and things like that. Then you can use that change feed to create aggregates with the data, or to shift that data off to your data lakes or whatever other analysis platforms you want to use.
Very cool. Very cool. Yeah, we'll come back to one or two of these things that you mentioned. What is? I know the answer to this, but what's the? I can hear an echo now. Let me just click on this. That's probably better. How does Azure Cosmos integrate with other services? Is it easy to integrate things like functions and things like that?
Oh, sorry, I lost you for a minute there. Sorry, what was the question?
How easy does Cosmos DB integrate with other services?
I think I need to change the echo on my side.
Can you hear me okay?
Yep, there we go. That's better.
So how easy does Cosmos DB integrate with all the other Azure services?
Yeah, so there's built-in integrations for a whole bunch of stuff. Most of it goes through that change feed, as I say. So you can go straight through to event hubs, event grids, Azure functions. So there's triggers for Azure functions stuff in there. There's even some neat things you can do by feeding Cosmos DB back into itself. So this is something we did. So we had a project where we're migrating data from old services. So we had like a Postgres DB, an old SQL Server, Azure SQL DB. So we're pulling all that stuff together, and because it's different databases, different schemas, pull those all into documents within Cosmos DB. And then using the change feed on each of those things, we could then set up a new collection with defined schema, and we could translate each of those different documents into like a common format. So we could then use that as the basis for pushing data into SQL Server.
That's a really clever solution, actually. Yeah, that's really cool.
So and there's plenty of examples of that sort of thing. Microsoft have got plenty of examples for IoT again, for example. So you might want to say, well, I've got all this data coming in, and I want to have an aggregate per day, or an aggregate per region, and things like that. So you can use the change feed again to create new data. Create these new data aggregates within Cosmos DB from other data that's in Cosmos DB.
That's quite clever, actually. What sort of use cases what projects have you worked on in the past using Cosmos? You mentioned a couple there, but what other stuff have you been doing?
Yeah, so I guess the two main ones I had. So there's the one which was this auction site. Think more like derivatives rather than like eBay. But it's like so the idea there was we need to have a real time view of these auctions for people all around the world. And because the primary data for an auction isn't that much. It's just like, here's what I'm selling, here's how much I've got, and then here's a list of bids. All we're doing there was just pushing those bids in as fast as possible into Cosmos DB. And then on the query side, we could then say, right, well, what's the most recent highest bid? We could do, we could check to make sure that there was no sort of race conditions things in there. We can make sure there was only one single winning bid at any point in time, and we can make sure that because we're only sending basically the diffs, which is just those bids, which is effectively just the user ID and then rank. That was very, very quick to get around the world, so everyone wherever they were in the world could get this consistent view of what was happening with that data. That was one big project we were doing, and the other big one I've done was this migration. And the key thing there was we're getting data from multiple different sources, pushing them through Azure Data Factory into Cosmos DB, and then pushing data within Cosmos DB, and so we could reformat that data. We could find inconsistencies between the data. So we're having things from multiple databases, but all for the same user. So we could do that consolidation piece within Cosmos DB and say, right, well, we know that this is the user ID here, this is the user ID here, this is the email address. Therefore, we know all these records are the same record, and then have that consolidated view within Cosmos DB that we can then use to fire off into Azure Functions to do a migration.
Very cool. I spoke to a guy called David O'Brien, who's from Australia, and he's running a cloud security software startup, and he's using basically, I said to him, "Are you using AKS?" And he's like, no, I'm just using functions in Cosmos DB. And he runs the whole solution for next to nothing because he's basically scanning other people's environments, getting that back as a document and storing it in Cosmos. And he's like, it's literally not cost me anything, which is amazing. I mean, I don't think people realize that you can build like startup companies using things like Azure Functions and Cosmos DB, because he gets like, I think it's like 30 million. I think it's 30 to 40 million Azure Function calls a month, which is pretty much not a lot of money. And then he's got the Cosmos DB, and it's not using 25 gig a month, so that's pretty much free as well. But yeah, very cool stuff. Very cool stuff. What is your tips for optimizing performance and keeping costs down? Do you just need to keep massaging the queries and making sure that you're doing the right things with partition IDs and index tuning and things like that? Is that what keeps the cost down?
Yeah, that's really the key thing. It's thinking about the query part of it, and because a lot of the cost you get with Cosmos DB is getting that data back out again. So pushing the data in is, I say, fairly straightforward most of the time. It's like you've got 1K's worth of JSON, you push that in, that's like 1 IU. You're not going to get much. There's not much you can optimize on that side. But yeah, you need to make sure you got the right partition keys. I think how that data is structured, how the data is going to be saved into onto the storage. And then also thinking about like the main queries that you're going to run. So are the main queries you're going to run going to be per user? Are they going to be per country? Are they going to be whichever it is? What you'd hope to find is that 80 to 90% of your queries will be running against that partition key. So something like a user ID or an order ID sort of thing is probably the best thing to use there. But then you are going to have other queries which are going to be which you want to optimize for other things, geographical or whatever. And the other thing to really think about is you don't necessarily have to do all the queries off the same database. So as I say, you can have these aggregates. So you can have one database which is optimized for that writing part of it, and then you have other databases which are optimized for here's the user reading, here's the user information, and then here's another one which is your aggregate information. And there's going to be different audiences for those things. But you can optimize the queries within each of those collections to make sure that you're getting the best response. And obviously, by having that optimization, you're going to be reducing your costs.
Cool. You've talked about change feed a couple of times. What is change feed for people who don't know what change feed is, and what? I mean, I know what it is, and I think it's amazing. But how do you explain the benefits of what change feed is for people who don't know?
Yeah. So the I guess the key thing with the change feed is that it's a view of every change that happens to the database. So so ultimately, it's effectively your audit log, right? So you can see everything that's coming in, every change that's made, every update. And as I say, that's what most of the integrations with the rest of Azure run off. Because you're reacting to all these changes, new documents, updated documents, these sort of things. So really, what it does is it gives you that that timeline view of what's going on in the database. So rather than seeing the database as your as it is now, it shows that history, which then allows you to make a lot more decisions on what's going on there. So I say things like creating those aggregates, things like pushing out data that matches particular criteria. So if you want to send out those notifications for temperatures and things like that. So it just gives you that additional layer that you can operate on beyond just what you can see in the data.
So I hear an echo again. Hang on, let me just check the audio. When you're updating the document, so let's say we're looking at the auction website, right? And you bid and then I bid. So we're updating possibly the same document. How does it deal with history and like what's the E tag is basically what explain to people what the E tag is all about and kind of how it knows who did what.
Yeah, so the ETAG, yeah, it's a common standard. Yeah, it's not just a thing in Cosmos DB, but yeah, the idea with the ETAG. So as you're doing your RESTful calls against the data, what you can do is you can say, right, I've retrieved a document. That document is a particular point in time, and you can have an ETAG which represents that document at that point in time. So then when you go back to update that document, as well as giving the document ID and the new data, you also provide that ETAG. And if the ETAG does not match the ETAG that Cosmos DB has, then it will tell you that there's conflict in that data, and you need to go and retrieve that document again. So that means that in this distributed system, you can check and make sure that you're not overwriting existing data. Now, it's optional checking that ETAG. So if you're building something for other developers, it might be the sort of thing where you want to put a wrap around that and make sure that all the times you're doing this, you do check that ETAG. But there's certainly occasions where you don't care whether you're overwriting data. So it's having it optional is a good idea. But yeah, if you do want to check for that, you need to make sure that you will always get the ETAG down, but you need to make sure you send that ETAG back. And there's a flag to set to say basically fail if this ETAG doesn't match.
Yeah, that leads me on to like conflict resolution, because I remember when I was doing RavenDB, like what we would find is I would say go and update record 10 and someone else would try and update record 10 and it would conflict. So how do you get around that kind of stuff? How does it deal with two people trying to update the same thing at the same time? Is this still the ETAG thing?
So ETAG is one way of dealing with that. So that's obviously a client-led solution. I'm just sure that So the other sort of way you can get conflicts is where you've got multiple write multiple write nodes, or you've had to do a failover to another write node. And what happens in that case is that any conflicts that you get end up in their own conflict collection. So alongside your main collection that's got all your data in it, you'll have a conflict collection which will contain all the records that it couldn't reconcile. So what you can do then is you can set event triggers on that collection, and you can say, right, well, there's any conflicts that have happened, then let's go and have a look at that data. Let's reconcile. And then obviously the reconciling that depends on your business logic. But yeah, you can say, right, well, here's the bid that's come in for that particular auction. That bid either does or does not exist in the live auction data. So in our case, it was just a matter of, well, we've got a list that's got all the bids in it. We can just insert that into the correct place in the list. It's ordered by date time. But there's obviously other scenarios which are a bit more complicated than that. But the idea is that you've got that conflict feed that you can interrogate and find out what has gone wrong, what the data is, so that data doesn't get lost. But you also need to go in and change that yourselves. If you've got the ETAG and you can do it that way, that's a better way of doing it. But that's not always possible, depending on how much data you're getting through.
Yeah, totally. What sort of, I remember one of the things was one of the SLAs is something like it guarantees sub 15 millisecond query response time. Is that still a thing, or was that a thing at the beginning of Cosmos?
So I think there's some caveats on that, but the basic idea is that you can retrieve a document. I think the restriction was you can retrieve a document by ID. So it wasn't necessarily a query; it was a document retrieval. So document retrieval, you can do it by ID because that's on the partition key. So that's the most optimized you can get. Queries are a bit more. It's very easy to write a query that takes a lot longer than that. As soon as you've got a query that goes across multiple partitions, that slows down dramatically. How do you sort that? Is there any kind of data modeling you have to change, or how do you deal with that? So it depends. It depends on the data you've got. So certain things like So I was talking before about you've got your user data and you've got a profile picture in there, for example. One thing you might do is actually move that profile picture out into blob storage. So the size of each of your records is much smaller. And then you just got a URL in for the profile picture in there. So by having smaller data, you're much more likely to get all that data to fit into a single partition. if you've got particularly, and as I was saying before, there's certain things which you're going to have lots of lots of queries that you expect to see. You might want to either index that or create a new collection that's specifically optimized for that kind of query. But again, it's very much depending on your use case. And what I'd recommend is you start thinking about what those queries are going to be, but then if you start seeing any performance issues, or as you start to develop that database, even if you're using the emulator, you can check and see how many IUs that query is going to take. And so long as your test data is reasonably representative, you'll be able to have a good guess to see whether that partition key is the correct key, whether your indexing is correct, or whether you need to create new collections for particular types of queries.
Okay, I think I've probably got 1 or 2 questions left on Cosmos DB stuff, but does it support transactions?
So it's not, to be honest, transactions isn't something I've been using too much on. So I couldn't say too much there. Like all the stuff I've done has just been using that e-tag for checking for the consistency stuff. But that's all I've been using it for. So
no, that's fine. And see how you've got serverless. Sometimes you're in SQL, you've got serverless and you've got consumption. Does Cosmos DB have things like serverless?
I'm trying to think. Yeah, because I know there was some stuff around new plans in the latest build, but I can't remember the exact details of them.
Oh, that's fine.
Because most of it has been, most of it is based on you've got your fixed number of RUs, and you're just scaling based on that. So it's kind of similar to the Elastic Pool you'd see in Azure SQL. It's that kind of model, rather than a sort of a fixed resource model.
Yeah. Okay. I was going to put up a couple of banners. If anybody wants to try Cosmos DB, I've got echo again. Hang on. Go there and try it. So plus you've got the emulator and things like that. There's also the Cosmos DB. I'm still here. What is there any new features that you've looked at roughly?
So I think the sort of the most interesting thing I've seen recently have been there's been a few tweaks on the C# API recently. So I've been using that quite a lot, and it's certainly a lot nicer to use. So it used to be that it was very hierarchical, and the API sort of kind of followed the hierarchy. So it's like create a database, create a collection within the database, create items within the database. And the new API is certainly a lot cleaner in that respect. So it's much smarter being able to get things up and running quickly, connect to what you want to connect to. So that's that stuff. And I do quite like the hierarchical indexing. That sounds like a really good idea. As I say before, having your sensor and your timestamp as 2 separate parts to a partition. That's really going to help being able to query against that kind of data. So you can make sure that you've got partitions that automatically adjust based on how much data you're getting in per user, per sensor, per whatever your business model uses.
What's your favorite thing about Cosmos DB?
Ooh, that's a good question.
There's lots of good stuff.
Yeah, so I think the thing that sort of really the thing that really surprised me, and I thought the thing that's been most makes me happiest about using Cosmos DB is what we're doing with that auction stuff. That ability to be able to get that data around the world really quickly. It's just you don't have to worry about any of the replication stuff. You don't have to worry about any of the any clever stuff around there. It just deals with it. It's amazing.
If you don't mind, explain how easy it is to set up replication to a new region. What's involved in doing? Because normally most things to do that is quite tricky. But how do you do that in Cosmos?
So the first step is you go into the portal, you go into Cosmos DB, and you tick a box going, I want to do it in Europe now. I want to do it in Australia now.
When you see that, it's just like, wow, that's so cool. You basically click on the region that you want, and that's it. It does it, and you're like, "This is amazing." Yeah, I think that's one of my favorite. The quick starts are quite good. If anyone's not played a bit with it and wants to try it, definitely try out the website that I showed. But the quick start tutorials are quite good to get up and running because I think a lot of people struggle with the concepts of Cosmos because most people use the SQL Server, and it is quite a mind change.
Yeah, I think the other thing that I really enjoyed with Cosmos DB actually, if you're using this was using the C# SDK, is that you can basically build the entire thing out from the SDK. So if you want to create your developer database, your production database, your database in all different environments, you can just do that all programmatically. You can just you can have your JavaScript, TypeScript code in your repo. You can upload that as part of your deployment, so that you've got your new UDS store procedures all set up in Cosmos DB, and it's all just using the same API that you use in your actual code. It makes that sort of thing so much easier to do.
I honestly think most of it's a joy. I just think when you're used to SQL, it's a little bit takes a wee bit of time to get used to it, but once you start using it, it's one of those things where you're like, I'm going to use this for every project. That's how I felt when we were doing it. Yeah, we were using it. I can't remember what we were using it for. It was for, I can't remember what it was for actually, but when we were using it, it was like, this is awesome. And that was a long time ago, so I'd imagine it's only got better. Okay, so you've started a new job, a couple of weeks' time. Looking forward to that.
Yeah. So it should be good. It's all working on net zero and Internet of Things stuff. So should be good. Looking forward to it.
Going to try and get a bit of Cosmos DB in there as well, if you can.
We'll have to see. I'm talking to the architect next week, and we'll see what we come up with.
And what about the exam? Have you taken there's an exam for?
Cosmos DB. So I was one of the first to take it. I actually took it as a beta when the exam was in beta. So there was certainly a lot of questions on MongoDB when I was doing it, and just like I have never used MongoDB, so half that was guesses. But I did. So there is an exam on it. I think it's definitely worth doing it if you're interested. Learn a bit more about like the data models, the consistency models. So
if people want to reach out to you, Craig, where's the best place to get you? Is it Twitter or LinkedIn or your web blog or what? Because you've got LinkedIn.
Yeah, probably LinkedIn. Probably LinkedIn's the best for now. My blog posts will get forwarded onto there as well. You can see that I'll be resharing, I'm sure, more stuff about Cosmos DB in the next few months anyway.
And do you have got any plans to go on holiday before you start work or anything like that?
Just got back from holiday.
I
got back. School term started last week, so
the weather's got better. Where were you on holiday? Were you somewhere nice? Somewhere warm, I hope?
Orkney and Shetland.
Very nice. What's it like up there? I've never been. I heard
it was beautiful. It was like sunshine. Like you got these really clear beaches. It was absolutely apart from one night when it was really, really windy. But absolutely beautiful. I recommend anyone go up there. Just get a camper and just go and explore.
2 or 3 people went there that I know this year, and they keep saying that. I might need to check it out. What about conferences? You got any conferences or talks or user group sessions lined up or anything like that? Or just concentrating on the new job?
Yeah, just been concentrating on the job hunt at the moment. But I'll keep an eye out for what's coming up. There's certainly a few things I want to talk about in terms of security side of things. When I gave a talk last year about the Pixie stuff, which is now available in Azure AD. So if you've not seen it, definitely go check that out. Azure AD spas, you can do all your login stuff without any secrets going to the client, which is absolutely fantastic.
Nice. That is good. That is good. Right. Okay. Well, thank you very much for coming on. I hope the people enjoyed this. Please do check out Cosmos DB. I think it's brilliant. I really do. The more I used it, the more I got into it, the more I liked it. Absolutely brilliant. Just before we go, on Thursday, I have another session with an ex-colleague of mine. It's a lady called Sandra Schneider-Dragon, and we're going to be talking about SAP on Azure. ADHD, and a few other things as well. So she wants to talk about that, which will be brilliant. I'm really looking forward to that. And that's at 7 o'clock on Thursday. Craig, thank you very much. If you ever want to come on and talk about anything else, please just drop me a message on that. And just stay on, and I'll play the outro music, and I can have a quick chat to you before you go. But thanks for joining, everyone, and do the usual, press subscribe and like and all that rubbish. But thanks for your time.